let's just knock this out of the way. With this problem, basically what you're going to do is I've kind of set it up so that it seems like it's just going to be a 3, 4, 5 triangle. This is a very typical right triangle based on what was told in the problem. So essentially, we don't need to solve any of this with numbers. We first just solve it analytically, and then you can plug in the numbers at the end, and I'll tell you how to do that. So I started with the principle of superposition. The really interesting thing about the electric field with static electricity is that the electric field on a point is the sum of the electric fields due to each charge. So this is the electric field due to charge 1. Sorry, just a moment. Okay, so this is the electric field due to charge 1, and this is the electric field due to charge 2. Now, basically, so the name of the game is we need to find the electric field at point P from 1 and from 2. So at P, that's usually where your test charge is, and we're basically trying to find what electric field do we feel at point P. Well, to do that, we simply just take the formula for the electric field, which is 1 over 4 pi epsilon naught, and we sum together each field. So again, the formula for the electric field, let me just put the generic formula just so that we're not thrown off here. So it's 1 over 4 times pi times the permittivity constant times the charge and divided by the distance away from the charge squared. And it always has a direction, and it's in the r hat direction. Now in this case, we don't need to worry about the r hat direction because it's specific. So if we look here, if Q1 is a positive charges do what? They diverge, correct? So the field is diverging this way from point P. All right, so that's going in the positive x hat direction. And then electric field 2, due to the negative charge electric fields converge. So Q2 is pulling up on P. So that'll account for that negative up here. And we won't need to worry about that negative value because I'm already accounting for it being pulled up towards this positive y hat direction. So that's where I get the x hat. We have the electric field 1. This is E1 due to E1. Diverging and pushing up, pushing to the right on point P. And then we have the electric field due to charge 2 pushing up on point P. So we could just put an arrow going straight up. Electric field due to 2. And then we basically just find the superposition of the electric fields right here using the distance formula. Or our Pythagorean theorem, either way you want to see it. So this is really E1 on point P, and this is really E2, and this is E total. Now when plugging these values in, be careful. You can keep the charges in coulombs. So this is another way of just writing the units. We can keep the charges in coulombs, and that's completely fine. But we need to convert centimeters to meters, and how do you do that? So 5 centimeters, and actually, R1 is going to be 3. So let's erase this. So R1, the distance between point P and charge 1 is 3 times 10, and this is shorthand, times 10 to the negative 2 meters is the exact same thing as 3 centimeters. R2 is going to be 4 times 10 to the negative 2 meters. Okay? Now you can plug in your coulombs, and then K is going to be 9 times 10 to the negative 9 Newton meters squared. And that's why we're converting to meters, because Newton's base is based off of meters, and also We have meters here. So you essentially plug those values in and you'll get the magnitude of the total electric field at point P, and you are done, and hopefully you can figure it out from there. All right.